Day 12 of 90. Today we are building a DNS Reconnaissance toolkit in Python. DNS is where every engagement starts. Before you touch a port scanner, before you test a single web endpoint, you need to map the target's DNS footprint. We are going to use the dnspython library because the standard library socket module gives you almost no control over query types, name server selection, or error handling. With dnspython you get a proper resolver object that can query any record type against any name server with configurable timeouts. Let us start with forward lookups. Import dns.resolver, create a function that takes a domain and record type, call dns.resolver.resolve, and iterate the answers. The critical part is the exception handling. NextDomain means the domain does not exist at all. No answer means it exists but has no record of that type. Timeout means the name server did not respond. Each scenario gives you different intelligence. NextDomain on a subdomain means it is not registered. No answer on a quad A query means the host is IPv4 only. Timeout might indicate rate limiting or a firewall dropping your queries. You need to handle these separately in your tooling. Now reverse lookups. You have IP addresses from previous scans and you want to discover what hostnames map to them. Import dns.reversename, call from_address to construct the PTR query name, then resolve it. Wrap this in a function that sweeps an entire IP range using the IPaddress module. On real engagements, reverse DNS sweeps on the target's IP blocks regularly surface internal hostnames, development servers, and services that were never listed in forward DNS. A host named staging-db-01.internal.target.com tells you exactly what that box is running. The naming conventions alone can map out an organization's infrastructure. Next up, MX, NS, and TXT records. MX tells you where email is handled. If you see Google or Microsoft MX records, that tells you their email provider. NS records show you who controls the DNS zone, which helps identify the hosting provider and potential attack surface on the name servers themselves. TXT records are the real gold mine for recon. Organizations store SPF policies, DKIM keys, and domain verification tokens in TXT records. I have personally seen engagements where someone pasted an API key into a TXT record as a domain verification value and never removed it. Build a function that queries all three record types and specifically parses SPF records. Flag any SPF record using +all because that means the domain permits any server to send email on its behalf. Zone transfers. AXFR is a mechanism for replicating DNS data between authoritative name servers. If a name server is misconfigured and allows AXFR from any IP, it will dump every single record in the zone to anyone who asks. That means every hostname, every IP mapping, every service record, all in one query. The code uses dns.zone.from_xfr with dns.query.xfr to attempt a transfer against each name server listed in the NS records. Most modern name servers restrict AXFR to authorized IPs, so you will get a transfer error on most targets. But you should always check. When it works, you get a complete inventory of the target's DNS zone in seconds. That single misconfiguration can save hours of enumeration. Finally, subdomain brute forcing. Combine the forward lookup function with a word list and threading. Read the word list file, prepend each word to the target domain, and resolve them all using a thread pool executor with 20 threads. Single-threaded enumeration against a 10,000 word list takes minutes. With threading it finishes in seconds. The key detail is handling the three exception types cleanly inside each thread so a timeout on one subdomain does not block the others. Store the results as subdomain and IP pairs so you can feed them directly into the next phase of your assessment. That is the DNS Recon toolkit. Forward lookups, reverse sweeps, MXNSTXT enumeration, zone transfer attempts, and threaded subdomain brute forcing. These 5 capabilities cover the DNS phase of most security assessments. Each one feeds into the next. Your forward lookups give you IPs. Your reverse sweeps give you hostnames. Your record enumeration reveals mail and name server infrastructure. And your subdomain brute force expands the target scope for everything that follows. Tomorrow on day 13 we move into HTTP reconnaissance, using today's DNS results to probe the web services running on discovered hosts. See you then.